found and downloaded some PDFs to read about flying squirrels. You found and downloaded 2 data sets at a minimum, potentially a third one. If you are asking a question that involves needing to know which counties or how much is in each county, then you also need to go back to the Tech Center's website and download the county boundaries data set. So if you search for boundaries or counties, you should be able to find a 1 to 24,000 scale data set there that you can download to your Data 1 and extract to your Data 2 folder. That will do very well for that. And that is also in UTM NAT 83 Zone 17 North, and so you won't have to tinker with it. It's good to go. All right, so let's look at, now that you've got this data, how do we construct the model? Things that you got to consider: standardizing, weights, and the map algebra. Um, you have to standardize your variables because, for example, how do you add pine tree to 6,000? You can't. So you have to convert all of your data sets into similar numeric terms, or use a data set for a specific function. I'll give you an example. You can take a data set and classify it as a Boolean data set, ones or zeros, and use it as a means of reducing the size of the area you're looking at by eliminating all the places that don't meet a specific criteria. And so everything that meets the criteria becomes a 1, and everything else becomes a 0 or no data. And if you multiply that by other data sets, those other data sets simply only become whatever is left in the area of that data set. And so that's one way that you can use it. But if you're using multiple inputs, they have to, if you're going to add them together as part of some cumulative score, you have to be able to have them in the same scale. So there's lots of ways to do that, and we'll cover that in a lecture at some point, and you'll utilize it a lot more in GIS 201. But we're making a simple 1-0 Boolean model of flying squirrel habitat where things either meet a criteria or do not. So we're going to reclassify our elevation and reclassify our land cover into data sets of 1s and 0s, so that when we don't have to weigh anything, because it doesn't matter how you weigh it. It's either a 1 or it's a 0. And so when you multiply them together, you either end up with an output that's a 1 or an output that's a 0. A 1 means you met both criteria. A 0 means you didn't meet one of the criteria. And if you don't meet the criteria, it's not habitat. And basically, that's the overlay function we're going to do with the 2 data sets that's going to allow us to do this map algebra that's going to generate that output. All right, so let's take a look at what we've got here. We are going to make some changes to our elevation data set, and we're going to use the reclassify tool to reclassify our elevation. And you see, if you open up your attribute table if you run the reclassify tool, it shows you the various elevation ranges that it's selected. We're going to simply click the classify button right there, which will then give us the classification tool where we can change it to 2. And the reason we're going to change it to 2 is we've only got 2 classes of elevation. Meets our criteria or does not meet our criteria. 1s and 0s. In this example here, I used 900 meters elevation because I was just being lazy and I couldn't remember if it was 909 or 910. So instead of looking it up, I punched in 900. Do not use 900, okay? It's 909, I think, or maybe 910. Whatever it is, you look it up and decide, pick a number and go with it. Essentially, you can go over there underneath where it says break values and just change that number, and put it wherever you want that to be. I simply typed in 900 and then that set my classes up. Right there is where I selected and typed in 900. Once you do that, it changes the look of your reclassify window. And the old values are on the left column there under reclassification, and the new values are on the right. I went in underneath the new values, and everything that was 64 to 900 meters, I changed that to no data, and everything that was 900 to 1482, I made a 1. The reason I chose to do no data is because this is just going to give me the cells that are above that and absolutely nothing else. This, in theory, should make the processing of my other data sets a little faster. Remember to look at that output raster box, pick the folder where you want it to go, your data 2 folder, give it a name. I called this one Student Elevations, and then click OK. There's where I made the changes. And once I did that, it gave me this output. This is the output that shows my values of 1, that being elevations above 909 or above 900 meters, which is my number I was using. That is all the spaces that meet my first criteria for habitat. Another thing you got to remember is that means that no matter what we identify in the other data set, if it's not in these slate blue colored areas, it's not going to be habitat. It has to meet both criteria. Briefly about standardizing our forest types, and this is just an example. This does not mean this is the ones you have to select or that you even should select. I'm simply pointing out that if you look in that text document in the land cover folder, it'll tell you that mountain conifer forest occurs in the highest elevations of the state, may include small pure stands of red spruce with balsam fir, with secondary amounts of yellow and paper birch. That sounds pretty much like really good flying squirrel habitat, so mountain conifer is a good choice. You might also select these or others. In this case, I used 4, and of those 4, I'm going to reclassify them to a value of 1. And everything else will become a 0. So if we were to take the same sort of data sets that we did before, use the same reclassify tool, it opens up, change the reclassify fields box to name. That way we can see what we're actually reclassifying. Under old values, it has the names of the various classes, and under new values, I simply put in the value that I want. Barren land and mining construction is a 0. Conifer plantation is a 0. Cove hardwood forest, maybe that's one I like, it becomes a 1. Go right down the list like that till I take care of all of them. And then my output raster, look where it's going. In this example, you can see that it says default geodatabase in ArcGIS. That's not the folder that I wanted. I should have said to put it in my data 2 folder and gave it a name like land cover stew or LC stew or something like that so I know what it is. And then click OK and click Save and click Run or whatever comes next, and it will generate a brand new data set, which you see over there on the left in my table of contents. This data set indicates all the stuff beforehand, but after I run this classification, I'm only going to have 2 classes of stuff. So let's take a quick look at what that's going to look like. I can pop open that unique values, and I'm going to have 1s and 0s and nothings, and I can get rid of stuff simply by selecting on it. But ultimately, at the end of the day, my 1s and 0s I'll leave, but I'll get rid of anything else that's odd. And I'll get something that looks very much like this. 1s being the right type of land cover, 0s being something else. At this point in time, we'll finish up the basic student type model, the kind that you're going to make the Boolean model, the 1, 0, the yes, no, the true, false kind of scenario. So we're going to do some map algebra, and if you're not familiar with map algebra yet, you will be soon. It allows us to do things like simply multiply one data set by another data set. And so locations that have values of 0 will end up as 0. Locations that don't have any data will end up with no data. Locations that have a 1 and a 0 end up as 0. Locations that have a 1 and a 1 end up a 1. So our elevation and land cover data sets, they're not weighed differently, they're weighed the same. Each one is Boolean. Each one has a correct equals 1, incorrect or no equals 0. And so if we simply combine those two layers using map algebra, in other words, multiply elevation, the final elevation layer we have, by the final land cover layer we have, we get a new output that we can save somewhere that'll be our final habitat. Everything with a 1 is the habitat. Everything else is not. So let's take a look and see what that looks like. All right, we're going to use map algebra. Map algebra is in Spatial Analyst. Inside map algebra, we'll find the raster calculator. It literally lets you select layers just like it's numbers. So I selected my land cover stew, hit my multiplication button, and then selected my student elevation data set. I went down the output location. Didn't like that, so I clicked on the folder. That opened up the output thing there on the left to where I could find my data2 folder where I want to save it. It's going to be a raster data set. I called it HAB Model 1. Hit save, hit OK, hit run, whatever to make it all go. And there you go. I get this habitat model of 0s and 1s. When I'm mapping this out and looking at it for my purposes, I really don't want to see them 0s. So I decided to do another reclassify step, and I took the 0s and made them no data and left the 1s 1s, put it in the location that I wanted and ran it. Got a nice set of data looked like this. Right clicked on the data set, my second reclass of my habitat model. Right clicked on it and looked at the attribute table, and notice there it says object ID 1 value 1 count. That means the only thing in this data set are my cells that ended up with a score 1, and from the count I know exactly how many. Turns out if you want to figure out the area of something, you multiply the width by the height. And if you've got a grid and you want to find the area of all the cells you've selected, you simply take the count of the cells, which we just found, being 4 million, let me see here, 4,028,516 cells. And if I were to multiply that by 30, which is the meter width of the raster cell, by 30, which is the meter's height of the raster cell, and then divide that by 40, I got 4046 here. I actually think it's 4048. But 4048 is that conversion factor. If you're not sure what it is, Google it. Do that simple math and it'll convert that number of 4 million something into a manageable number. Something like 896,110 acres of habitat. That's literally all you have to do in the most simplest form for your project. If you can come up with a scenario to where the question that you have to ask is how much habitat is there in West Virginia, at this point in time, what the steps we've done would have given you your final answer. Now, if you took it a step further and asked how much is in each county, there's another tool that's in the Spatial Analyst down at the bottom. It's called Zonal. And inside Zonal, there's a tool called Zonal Statistics as a table. And you would simply put in your counties data set and use the name field of the counties and have it use that as the zones. And this data set we're looking at here, this reclass raster one, would be our target raster. and it would look at each county and say how many of these cells with a value of 1 are inside this boundary of this county, and it would give us a table showing that. We could then do the same math we did here and figure up acres on a county by county basis. But if you want to for the interest of simplicity, not overcomplicate your life, make sure you come up with a contrived question that asks something simple like, how much habitat is there for the flying squirrel in West Virginia? So that pretty much means at this point in time you have a habitat model that is made. In the next video, we'll look at running that zonal tool for those of you who decide to go one step further, and we'll look at how to take this information, make it into basic maps, and how to put those basic maps into a poster. And we'll briefly talk about writing all that up in your final report.